Hello, and welcome to the third lesson of the Math Modeling Introductory Tutorials. Today we are going to talk about the structure of the solution paper. However, the solution paper is a really complicated concept, and we are only going to cover an overview of it today. And we will also be going in depth into different parts of the solution paper in future videos. So, first of all, what is a solution paper and why is it so important? Well, in a math modeling contest, the solution paper is the only material you turn in after the contest, which means the judges will see the solution paper and nothing else. Therefore, it should detail all the important information in your model. Normally, it is quite long as most contests will have a 20-page limit, and most of you will be reaching that limit. And let's look at the structure of the solution paper. Okay, this seems like a lot, but it is actually simpler than what most of you may think. So, it starts with a summary, and you have introduction, assumptions and justification, variables, construction of model, implementation, analysis, and finally references. Now, let's start to look at these sections one by one. So, first of all, the summary sheet. Essentially, the summary is limited to one page, that is, the first page of the paper, and essentially, what does it do? It is basically a bit of everything thing. So, you put a bit of every part of your paper into the summary sheet. However, how should you put the bits and bits into the summary sheet? You should show the highlights of your paper, which means the most important and the best parts of your paper. Because the summary sheet is the first thing your readers will read, it is really important to get them interested through your summary sheet, or else they might not even read your paper at all. Next up is the introduction. So, the introduction has three main parts. First, you can provide a very brief background of the problem, and then you can restate and summarize the problem. However, a restate of the problem is not just a simple paraphrase. It is best if you show that you understand the problem and you can interpret the problem through your restatement. Finally, you provide a very brief overview of your solution, mainly focusing on your aim of the model, which we talked about in the previous video. So, for the Ebola problem we talked about in the previous video, the introduction may look like this. So we start by describing the background of the Ebola outbreak, and then we talk about what the problem asks us to do. However, we rephrase it in a way that shows that we have go beyond the superficial parts of the problem. And then we provide an overview to what we want to do in the problem. For example, minimize Ebola death. Now, the next two sections are assumptions and justification and variables. What assumptions? We have touched a bit of this in the first video. And essentially in the assumptions part of your paper, you just enumerate the assumptions and you provide some justification to why each of your assumptions is reasonable, so people believe that your assumptions are good. And then after that you have variables. So the variable section is to help your readers be clear with your model. So you define your variables all together, so it's really clear for people to see. And normally this takes form of a table. And now is the big part, the construction of the model. So this is the part where you put in all your math. So you have the mathematical methods that will lead to your model put into this section of the paper. Also, it is really important to put your logic clear in this section of the paper, and therefore people know how your model works and why it is reasonable and therefore useful. Therefore, you should incorporate some clear justification to each step of your model. And you will use figures and equations to assist your explanation, which we will also cover in more depth in a future video. After construction of the model, you still have things to go. Next up is the implementation of the model. Most math modeling contests will require you to implement your model. This is not always needed, but is strongly recommended because it shows that your model actually works. So, you implement your model by using real data, or maybe data that is made up but reasonable. So, it is a really important way to test your model to prove that your model is useful. After implementation, you'll complete a series of analysis. So, it will be in-depth analysis of your model, and it is best if you look at your model from different perspectives. And one of the simple and most important type of analysis is strengths and weaknesses, where you will explore what your model is good at and what your model maybe cannot cover so well. So, we will talk more about analysis in a future video. And that is all I have for a brief overview of the structure of the solution paper. And thank you for listening, and in future videos we'll be exploring more about how we make a good solution paper. Thank you.